Welcome to this explainer. We're going to uncover why threat modeling is, hands down, the single highest leverage security activity your dev team can actually do. We talk a lot about security tools and testing, but today, we're zooming in on the absolute foundation of secure software. It's all about catching those massive architectural flaws way before they blow up into incredibly expensive problems. So, before you write even a single line of code, picture this. You gather your team around a whiteboard, you shift into that hacker mindset, and you ask yourselves one deceptively simple question. What can go wrong? That's really it. You're just systematically working through your architecture, looking at every component, every data flow, and literally putting yourself right in the shoes of an attacker. Now, if you're wondering why we invest so much time here, check this out. According to NIST, fixing a design flaw is literally 30 times cheaper than trying to patch it in production. 30 times. A missing auth check? Well, during design, that's just a quick 2-line fix. But if you find that exact same flaw after release, oh man, you are looking at a brutal, time-consuming architectural redesign.
Okay, here is our roadmap for today. First, why threat model, then the 4 questions, followed by the 4-step process, stride, a practical example, and finally, some key takeaways.
Let's kick things off with section 1, why threat model, catching design flaws early. So why actually do this? Beyond just ticking a box for OWASP or some PCI DSS compliance framework. Well, think about it like this. Automated scanners look at your implementation, but threat modeling looks at your architecture. Sure, your SaaS scanners are absolutely fantastic at catching buffer overflows or bad syntax, but they are completely blind to architectural flaws. They are not going to catch a missing authentication check that requires a total redesign. Threat modeling forces your entire team to think like an attacker at that high level, catching those invisible flaws that automated tools just sweep right past. Moving right along to section 2, the 4 fundamental questions based on Adam Shostak's framework. At its core, threat modeling really just boils down to a simple framework popularized by Adam Shostak. Literally every methodology you've heard of, Stride, Pasta, you name it, ultimately just answers these 4 progressive questions. Number 1, what are we building? You've got to have that shared understanding across your team. Number 2, what can go wrong? That's your threat identification. Number 3, what are we going to do about it? AKA your mitigation plan. And number 4, did we actually do a good job? That's your validation phase. Seriously, keep these 4 questions in your back pocket. They're the engine driving this whole process. All right, section 3, the 4-step process, turning those questions into action. So to turn this into a super practical methodology for your next feature, step 1 is all about drawing data flow diagrams, or DFDs. You basically need a visual model your whole team can point at, mapping out your external entities, your processes, your data stores. But here is the absolute most crucial part, drawing trust boundaries. You have to explicitly mark where data crosses from a trusted zone into an untrusted one. Why? Because every single arrow crossing that line is a potential attack path waiting to happen. From there, steps 2, 3, and 4 are identifying the threats, assessing their risk, and mitigating them. Which brings us perfectly to section 4, understanding stride and getting into the hacker mindset. When it comes to actually identifying threats, stride is the heavy hitter. It originally came out of Microsoft, and each letter just represents a different category of threat. Let's think about an e-commerce checkout, right? An attacker might try spoofing by pretending to be another user, or tampering by altering the cart price while it's in transit. Add in repudiation, where they deny doing something malicious, information disclosure to steal credit card data, a denial of service to straight up crash your servers, and an elevation of privilege to make themselves an admin. Boom, you've got a complete, structured checklist to fire up your team's imagination. Okay, step 3 is assessing risk, because let's be real here, you just can't fix everything. The formula is simple. Risk equals likelihood times impact. A highly likely, high-impact threat, yeah, that gets immediate attention. But an unlikely, low-impact one, you might honestly just accept it. A lot of teams use the DREAD model here to score things. You're looking at damage potential, reproducibility, exploitability, affected users, and discoverability. Whatever model you choose, the whole point is just consistency, making sure you're always comparing apples to apples. Then we hit step 4, deciding your mitigation strategy. You've essentially got 4 choices. 1, redesign the system and eliminate the threat entirely. 2, apply standard controls, think encryption or input validation. 3, transfer the risk, usually by throwing insurance or third-party contracts at it. Or 4,
just accept the risk. But here is the kicker. If you choose to accept it, you absolutely must document that decision explicitly. Trust me, you are going to need a good answer 6 months down the line when someone inevitably asks why a known issue wasn't fixed.
Moving to Section 5, a practical example with file uploads, taking this from theory to code.
Let's ground this with a hyper-concrete example I know you've probably built before. Imagine we are designing a profile picture upload feature. In a quick 15-minute whiteboard session, again before any code is even written, we just flip that switch, get into the hacker mindset, and ask her favorite question: what could possibly go wrong with a simple file upload?
Well, suddenly, our innocent little image upload starts looking kind of terrifying. An attacker could completely bypass our file type checks by uploading a .php script that's just masquerading as a .jpg. Or they could upload polyglot files. These are technically valid images, but they've got malicious JavaScript embedded inside them. Or, thinking about that denial of service angle, they could just repeatedly upload massive payload files, exhaust our server storage, and bring the whole system crashing down.
But here is where the magic actually happens. Those theoretical whiteboard threats, they directly dictate the code we're about to write. To stop that file type bypass, we whitelist extensions and check magic bytes, just to verify that a JPEG is actually a JPEG. To stop path traversal, we generate random UUID file names and store them totally outside the web root. And to handle those nasty embedded scripts, we just make sure to serve files back with a content disposition attachment header. That forces a safe download instead of dangerous inline execution. Just like that, a 15-minute whiteboard session saved us from 3 critical production vulnerabilities.
Finally, Section 6, key takeaways. Let's wrap this up. We've gone from abstract models all the way down to specific Python code. So what's the big takeaway? Threat modeling is inherently a design phase activity. You want to use frameworks like Stride to really structure your brainstorming and apply a consistent risk formula to prioritize your mitigations. But above all else, remember that threat modeling is absolutely not a one-and-done audit. Do it early, whether you're moving to microservices or just building out a new feature, and keep it iterative. Review those models quarterly as your system grows and evolves. Which brings us to the final step of the framework. And frankly, my final thought for you today. Looking at your own systems right now, I want you to ask yourself, are you catching vulnerabilities on a whiteboard with your team, basically for free? Or are you paying 30 times the price to fix them later in production? It's definitely something to think about. Thanks so much for hanging out with me on this explainer, and I'll catch you in the next one.